In this calculus lecture, we are looking at higher order derivatives, which is basically let's take the derivative multiple times, or let's take the derivative of one term and then add it to another term and then take the derivative of that. Basically that idea. And it will sound a little foreign to you. You just have to do some problems. So online resources will be your best friend here, but I'll share some examples. In question 1, we're just going to look at taking the derivative multiple times. That's what higher order derivatives is part of. And then part 2, we have, okay, let's take the derivative of the inside twice here and then multiply it by x to the third and then take the derivative of that. Basically, how can we look at these functions so it just doesn't look like a bunch of garbage? So let's start here. This command is saying let's take the derivative 3 times of 20x to the 6th. Now, how do we do that? Well, so let's take 20x to the 6th and let's find the first derivative. So we'll just say, and this is not correct in notation, but dy dx is equal to, and we're going to take the derivative of 20x to the third. So we know that to do this, we have to do the power rule. The power rule states we just bring down the exponent, subtract the exponent by 1. So 6 times 20, how am I forgetting? 120. 120x to the 5th is the first derivative. We want to find the second derivative, dy squared dx squared, or sorry, it should be d squared y dx squared. Now I'm going to need a calculator because I don't know how to do my own math really easy. 120 times 5, that's 600. 600x to the 4th. Okay, that's the second derivative, and that we know that the third derivative is equal to, well, just follow the simple pattern here. 600 times 4, 2400x to the third. So that's the third derivative of that. Hopefully that makes some intuitive sense to us. We're just taking the derivative multiple times. You can also see notation as this for our derivatives, and this is a better way to say it than dy dx d squared over dx squared. You'll see f prime of x, right? We've seen that before, but have you seen this before? F prime prime of x, or f prime 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 of x, right? That's saying, this is saying the first derivative. This is saying prime prime, the second derivative, and prime 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 is the third derivative. Hopefully that makes sense. That's different ways that you'll see it. Okay, so we saw a very basic example of just some power rule derivatives multiple times. Now let's look at, okay, let's combination of derivatives is what it's called here. And basically, the best way to go about this is just to break it down. So let's first do this portion here. We are asked to find the overall derivative of x to the third times the second derivative of x to the third. Basically what it's saying. So I think it's best just to simplify what we have in here, right? The second derivative of x to the third. So what is the second derivative of x to the third? Well, we know it's x to the third is just the normal function. Bring down the exponent, subtract by 1. That's the first derivative, so f prime of x. F prime prime of x is equal to, well, 6x, right? So we could just substitute 6x here, right? Because we know that the second derivative of x to the third is 6x. All right, so we do that, x to the third on the outside, and we're told to take the derivative. Now we could do product rule, but I'm not going to torture you, so I'm just going to multiply the two terms together and then take the derivative here. So we're going to say that dy dx, we're still not taking that derivative yet. Multiply this, 6x to the 4th, right? Pretty simple. We take the derivative of that, so we say that dy dx is equal to, and we're going to see that that is equal to 6 times 4, that's 24x to the third. So those are higher order derivatives. Now, higher order derivatives, remember, that's just taking multiple derivatives or putting derivatives inside derivatives, kind of making some kind of complex problem there that you're likely to solve. There's not really anything else that we need to talk about here. Kind of just a simple thing. But in the next video, we're going to be looking at, I believe, implicit differentiation. So, and that's taking a derivative with respect to one variable and others with respect to that variable. So, I hope you guys enjoyed. Have a wonderful day.